Good morning, good afternoon, and good evening. This is Phil Edholm. Welcome to today's webinar. This is an exciting topic. We're talking really about how WebRTC is transforming the industry, how it's changing the way we build applications and the way applications work, and actually making very major changes across the industry. Today is an exciting day. I'm actually joined today by Ted and Anton Venema. They are actually the founders of Frozen Mountain and are going to talk to us today about the work they've been doing in enabling real-time using IP across a range of applications and some new technology they're bringing to the market to help with that journey. So with that, I'd like to hand it over now to Ted Venema, and Ted is going to talk to us a bit more about his experiences with, as they have focused at IRTC, and how it can work in terms of the real-time world. Ted, throw it off to you.
Thank you very much for that introduction, Phil, and thank you for that excellent summary of WebRTC for us. Before we get into the actual presentation, just one slide quickly to tell you a little bit about Frozen Mountain, who we are as a company. Frozen Mountain was founded in 2008 by two brothers, Anton and Jared Venema, so we've been in business for about 10 years. And we specialize in internet-based real-time communications. We've done real-time communications since day one, and that remains our specialty in terms of the market that we're in. We have over 400 customers in 51 countries, and we developed all of our products from the ground up. So our expertise is not just in knowing about WebRTC, but actually developing WebRTC core products, as well as we'll talk about today, IRTC. In other words, extending, as Phil has already noted, extending WebRTC from its original roots into the market as a whole, which has now been expanding tremendously. Internally, we have a way that we term that just to help us along a little bit, because WebRTC, as the name sort of implies, kind of looks like it restricts to the web, but it's still implied that's not the case. So we've coined a word internally that we use, which is IRTC, Internet Real-Time Communications. And basically what IRTC is the use of the Internet. So the Internet forms the backbone for everything that's going on in terms of the actual low-level communication. Use of the Internet for real-time transmission, in other words, low latency, two-way transmission, not delayed transmission, not shipping files later on, but actual real-time communication of all types of communication data. So yes, audio-video, as we often think of and equate with WebRTC, is an important key component, but it's not the only component of what IRTC is. There's many other aspects to real-time communication that can enter into a real-time communication application. If we go back in history and look at WebRTC originally, as it was sort of invented, if we want to call it that, by Google and put into Chrome, one of the key factors to start with was the ability to support browsers in a very, very easy fashion. It was quite revolutionary when Chrome first came out with the concept that said audio-video communication based on a WebRTC protocol is now built into the browser. Browser people do not like downloads, do not like plugins if we can avoid them, and here suddenly was the capability to actually make use of transmission of audio-video without actually having to use a plugin. The good news in the browser market is that once Chrome adopted it, it was quickly adopted by Opera and by Firefox. Microsoft came along a little later. They were a little slower to get on board, but they have now more or less adopted, in particular in their Edge browser, not so much in Internet Explorer, but in their Edge browser, they have adopted WebRTC. And very recently, Apple finally announced support in Safari as well. So the dominant browsers in the market support WebRTC to some degree or other. I say to some degree or other because the actual support is not equal among the browsers. And one of the things that still makes dealing with WebRTC applications difficult is the fact that the browsers do support different capabilities and support them in slightly different ways. So as always with standards, there's always the fact that the implementation matters, and the various browser vendors have implemented some of these in slightly different fashions. As we'll see later, one of the things Frozen Mountain specializes in is providing you clients for both browsers and other platforms that hide all of that from you and give you one single standard API across all of the platforms. So the browsers were there. They were very good, and hence the name WebRTC, the browser being the front-end platform. However, it didn't take long before people realized that interacting with the browser is great, but it's not sufficient. So, for example, we need to have desktop platforms. We need to be able to link to things like .NET. We need to link to things like Mac OS or Linux. so that to link into applications that are running on a desktop but don't actually use the browser as their user interface. So that's another area that has rapidly developed, and there are many applications out there today that can make use of WebRTC protocols under the covers. That is, they're still talking WebRTC on the wire, but they actually act quite differently in terms of the desktop platforms that you can support. And of course, on top of that, we can never forget about our wonderful world of smartphones and tablets. These particular devices are also necessary and are very much ubiquitous in our world today. Same thing happens here. Interestingly enough, on smartphones and tablets, people are not nearly so adverse to downloading. In fact, we all download things from the app stores all the time. So in this particular case, including WebRTC protocols and having IRTC extend into the world of smartphones and tablets with native applications is also very, very important, and a very, very important part of what WebRTC is doing today and where IRTC as an overall concept encompasses as well. In addition to smartphones and tablets, we're now starting to see smart homes develop as well. Many different types of homes have automatic doors. Apartment buildings have automatic entry systems, whereby people can actually not only necessarily be at home, but can actually see who's at the front door of their building when they're actually in their car driving home still. So we're starting to see, with the fact of smart homes being developed and with so many different Internet of Things type devices being developed, we're starting to see more and more situations where people can make use of WebRTC protocols, but in areas and using devices that are very far away from the browser that was originally intended. The same thing is true for augmented reality and virtual reality. In this particular world, we start to see things like, of course, Microsoft's HoloLens and other devices hitting the market, whereby we want to intercommunicate that information as well, with information being sent from a source over to the glasses and vice versa, in order to be able to further augment the situation and augment particular video that they're doing. We see overlays for example, for when you're working on a car engine, you can now overlay the actual wiring right on top of the engine while you're looking at it. All of these kind of things are now starting to make use of WebRTC technology under the covers and are forming part of the true complete IRTC world that is not limited just to the web. And of course, then there's finally the wearable devices, our wonderful smart watches and everything else that we have. So we see that there's many, many different types of devices. And of course, one thing that we've also heard a lot of as you look at these, particularly the last three sections, smart homes, augmented reality, wearables, this is really the Internet of Things that we're starting to see develop. Because IRTC and WebRTC itself uses the Internet as a backbone, it's able to integrate very quickly with devices that themselves are now being very easily designed and implemented to interact with the Internet as well. So a very, very powerful way to look at the fact that whatever the Internet of Things is going to come up with, that's what we're going to have to deal with in the WebRTC, IRTC world. IRTC also includes many verticals. Phil already alluded to the fact that the original foundation of IRTC or even WebRTC was in the telecommunications world. But that has expanded its way out into things like telehealth, doctors talking to doctors, doctors talking to patients, doctors talking to hospitals. All of this intercommunication is happening to a much higher degree. The first, shall we say, round of telehealth was health systems that are largely within the hospital, but they're very rapidly moving to systems that now expand out so that doctors, nurses, patients, everyone intercommunicate with each other on a much, much broader network. Customer service is also being impacted by the world of IRTC. So for example, when customers are talking to a rep, they no longer just want to do a chat, they actually want to see the rep that's there. And the rep may well want to see the customer as well to know, well, what is their facial expression telling me? Are they really happy with the service I'm providing? Are they annoyed? Are they upset? Are they feeling frustrated? These kind of things are rapidly coming into the world, not only in terms of people being able to look at faces, but being able to do analysis on the data streams in order to determine automatically what the facial expressions are saying. Remote education, another big part of what we're seeing, the development of the IRTC world, where teachers want to interact with students, not just in straight long-distance learning, but actually want to communicate back and forth with the students, want to see what the students have to say, and will actually be able to watch and see if they're actually paying attention. And of course, just general application development. Even technology such as what we're using here today for this particular webinar under the cover can start to make use of WebRTC type technology and forms part of the IRTC framework as we move away from just the web, but into the full internet-based real-time communications. So as I've kind of noted a little bit, IRTC is more than just WebRTC. Now, first of all, it's important to note that WebRTC is a fundamental component of IRTC. We're not leaving it behind. It's still required. We still need to be able to do the audio-video conferencing. We still need to be able to talk to those browsers that are out there. It's fundamentally important. At the same time, however, we're going to recognize that there are other types of data that we want to share. For example, in a telehealth system, we may want to share blood pressure or heart rate or any number of other different types of data that's going back and forth among the various people. So it's not just about audio-video data, it's about sharing many different types of data in IRTC. Also, for example, we may want to make use of whiteboards. We may want to share information, have multiple people writing on the board at the same time, and have information shared automatically between the people. Once again, this is not traditional WebRTC type communications, but is an important part of many IRTC applications. And as we go through some of these, you may well see in terms of things you're looking for real-time communications that yes, you need WebRTC, but you also need some of these other forms of communication as well. Broadcasting is another big one, and it comes sort of in two forms: simple webinars, such as the one that we're on today, where we have one or a small group of presenters presenting to not a humongous audience, maybe up to several hundred users or whatever the case may be. But broadcasting also can actually now be impacted by WebRTC as well and by IRTC. It scopes in, IRTC scoops it in and brings the WebRTC technology to them by actually broadcasting out to thousands and hundreds of thousands of users at the same time. Of course, we can't forget about the fact that we do have a legacy PSTN and SIP-type technology. The original telephony world that to some degree spawned WebRTC is still out there, and we do have situations where perhaps in a set of conference calls we want to be able to dial in from traditional phone networks. So even though, again, WebRTC does not address this, the ability to link into legacy-type technology, it's hard to believe that we look at VoIP a little bit almost like legacy already. It's amazing how fast the world moves. But nonetheless, to be able to link into these traditional devices, which usually are audio only. Also, another important area that is developed is the ability to do push notifications on mobile phones. The ability to notify an application on your phone, even though it's not actually running, that something has come in and there's something to be there. This, of course, again, as Phil sort of noted earlier, we kind of expect to have the same kind of capabilities that we see on our phones. And after all, phones can ring fine and dandy when they're sitting in my pocket. So the ability for your application to do the same thing and put out push notifications to an application is a necessary part of what IRTC is all about. And of course, there's recording. We can't forget about that. The ability to record many of the audio-video conferences that are going on, or record your whiteboard sessions, or record your broadcasted sessions. So recording is a fundamental component of what IRTC is all about as well. And then last, let's not forget about the wonderful world of text chat. Let's not forget about this little guy that has been around since forever but is still needed. Many times we have audio-video conferences that are combined with text chat, as we do today, where you can send in your questions to us to answer at the end of the presentation. So text chat also, another important component of IRTC. Some of these aspects are hinted at with WebRTC, but the important point to notice is that the IRTC, using the internet as a backbone, works for all of these. Using WebRTC protocol on the wire works for all of these, even though the individual applications may be very different. At this point, I'd like to say we're going to do a little quick survey. So Phil, I'd like to turn the presentation back over to you.
Excellent. Thank you very much, Ted. I appreciate that. Appreciate all the great info. It's great the insight you have, from actually doing these developments, understanding what's possible. It's a really exciting time. So our survey today is, we actually thought it would be very interesting to ask all of you in the audience, and as a way of actually showing appreciation for your coming to this event, to ask you what you'd like to hear more about in the future. So, my level of experience with real-time communication is best described as, I'm learning about RTC. I'm the mastermind of RTC applications. I'm currently in the process of developing my first RTC application. I've developed one or more, or it does not apply. So the first thing we really want to kind of understand is, what is your level of expertise in this area? Are you a neophyte trying to learn, or have you done some development and trying to learn how to deploy? So take a moment and answer that. And while we let you answer that question, I actually have a question that came in for Ted. So this was actually a question that came from your discussion about data and how data is transmitted. And the question is, using WebRTC for transmitting data versus using WebSockets for transmitting data, what are the benefits of using WebRTC versus just using basic WebSockets?
Oh, I think the advantage is quite strong in the fact that under WebRTC itself, you're down at the lower levels making use of technologies such as UDP. WebRTC is founded on the principle that, at least if you use it in a non-reliable mode, that you can actually transmit data, and it doesn't hurt the odd time if you lose the odd frame of information. So, for example, it's quite all right if we're transmitting lots and lots of video images. If we lose the odd one, the eye is not good enough to be able to detect what the difference is. On the other hand, of course, and so that is what's happening, and that actually causes, of course, through WebRTC, a much higher performance level in terms of the transmission of data. If you make everything 100% reliable all the time, you're going to be transmitting much more data. There's going to be a lot more back and forth issues, and it's going to be a lot slower. This is in contrast to things like medical devices, where basically if you have a medical device, such as a heart rate monitor, you want to actually transmit small amounts of data, and you want to transmit them very, very accurately, in which case WebSockets would be a perfect way in order to transmit that. So it's important to know that in IRTC you would end up using both, just for different purposes.
So it's kind of seeing this as a set of tools you can use to implement these next generation capabilities, et cetera. So I think we're pretty much all set with the poll. Why don't we go ahead and push our poll results out there? So if we look at our poll results right off the bat, it looks to me like I'm learning about how RTC can fit into my business plans is the biggest part of our audience. And I think that's really to be expected. Ted, I don't know how you feel. I'm seeing an incredible amount of interest and desire to understand how these technologies can impact applications. Are you seeing that, Ted, in the folks you talk to?
Yes, very much so. I mean, for many people, WebRTC is still fairly new. They realize it's out there, and sometimes I guess they're waiting for their first application that requires it in order to look at it. But it's still, for many companies, still a new area where people are trying to look at, how do I actually? It sounds great. How do I actually make use of it, and how can I actually improve my applications by using, WebRTC and using IRTC, using all of these real-time communication capabilities.
Excellent. And for the 17.7% of you who have developed one or more RTC applications in the past, hopefully the next area we're going to throw it back to Ted to talk a little bit about is, what is Frozen Mountain doing to help you ensure that the deployment of those applications, the implementation and deployment goes smoothly and can meet your goals? So back to you, Ted.
Thank you, Phil. So I would actually like to introduce at this point Anton Venema, who's our CTO, to talk about LiveSwitch, which is Frozen Mountain's product which addresses all of the IRTC needs. So I'm going to turn the application over to him. Anton, over to you.
Thank you, Ted. So I'm going to talk a little bit more about, as Ted mentioned, about LiveSwitch and about some of the technical underpinnings that make it work. So to start out with, before we dive in too deep, we want to really understand three key terms which represent three different topologies when you're architecting IRTC-based applications. They are P2P, SFU, and MCU. So P2P stands for peer-to-peer, and it's the kind of the baseline topology. It's the kind of the framework around which WebRTC was originally developed, and it involves a topology where every device, every endpoint connects to every other endpoint. So in the illustration we have here, there are 4 endpoints in the call, and you can see that each endpoint is fully connected to every other endpoint. It forms this kind of mesh network. This works really well for two-party communications. They're able to talk directly from point A to point B without anything in between except potentially a turn relay server, which is sometimes necessary for firewall traversal. But what happens is as the number of participants in a call or a conference grows, the mesh network becomes relatively unsustainable. That's due to 2 things. First is the asymmetric nature of most bandwidth connections that are available. Upload speed is generally not as wide open as download speed. So if you had a download speed of, say, 150 megabits, your upload speed might only be about 15. And as you can see from this graph, your downloading and uploading is symmetric. You're uploading just as much as you're downloading. And that doesn't play very well to the nature of most internet connections. The other factor is just pure device limitations. As you can see from the graph, everybody's uploading to everybody else, which means that everybody has to encrypt and upload 3 times for every single video frame, every single audio frame that has to be transmitted. And especially on low-power devices, that becomes quite burdensome to the system. So what we recommend once you get past 2 or 3 parties in a call or in a conference is to use the LiveSwitch media server to do basically take all the heavy lifting and handle it for you. And there are 2 modes that you can run in with the LiveSwitch media server. The first is as a selective forwarding unit. And as you can see from this graph, what happens is everybody uploads their content once to a central server, and the server acts as a forwarding agent that basically forwards the packets around to every other participant. So this plays really well to the asymmetric nature of most people's bandwidth connections or internet connections. We upload once, and we download multiple times, once for each participant in the conference. This is very lightweight on the server. You can scale out quite high, and you can even scale out both vertically and horizontally. You can add lots of media servers together and cluster them together to support really high loads. But the flip side of that is that the client still has to process lots of downstream data. So if you had, say, 30 people in a virtual classroom, everybody's sending and receiving audio and video, that means that each person has to be downloading 29 individual streams and decoding and displaying them. And that's where the MCU comes in. So the MCU stands for a multi-point control unit, and what it does is it actually mixes all of the audio and video together on the server for you. It decodes all of the incoming streams, puts them all together into a single canvas for video, and then delivers that mixed canvas back down to every participant. And what that means is that each person that's participating in the call only has to open one connection to the server, one bidirectional connection. They send their media up, and they get everybody's media down. The flip side to that, the downside, I guess, is that it puts all of that load on the server. So there's a kind of a theoretical limit at which point you can't put any more people on the server. You can vertically scale. You can keep adding more CPUs, more cores, more horsepower to it. But of course, that does get expensive. So LiveSwitch is all 3 of those things. LiveSwitch can create peer connections, it can create SFU connections, it can create MCU connections, and it can do them all at the same time. The entire infrastructure is controlled by client-side application logic. We've designed it so that the servers are kind of dumb in a sense that they can be deployed using Docker or using any type of auto-scaling, and the clients themselves actually control the application logic. So at the center of it all is the LiveSwitch signaling gateway. This is an HTTP WebSocket-based signaling system. It is fully scalable, so you can put it behind a load balancer and add multiple gateways for redundancy and high availability. It handles client registration, it handles text chat and messaging, and it is the centerpiece around which everything else connects. So next up we have all of the LiveSwitch clients. As Ted kind of alluded to earlier, one of our key strengths is our client SDK platform support and our breadth of platform support. We support Windows, Linux, Mac, Java, .NET, Objective-C, Swift, Android, iOS, UWP, Xamarin if you're doing cross-platform development, all of the major browser vendors on desktop and mobile. Basically, if it's possible to have WebRTC support, there's a pretty good chance that we either have it or we can build it. So next up, we're going to kind of add into this picture the LiveSwitch media servers. So these kind of sit in the server in your data center alongside your gateways, and what they do is they handle all of the actual live streaming. So whereas the gateways handle all of the HTTP signaling traffic, that's relatively lightweight, the media servers do all the heavy lifting in terms of receiving all of the audio video streams, mixing them together in MCU mode, forwarding them out in SFU mode, handling any recording, that sort of thing. They take care of any transcoding. If there are incompatibilities between different client platforms, maybe one platform supports H.264 video only, the other side supports VP8 only, the LiveSwitch media server is what's going to sit in between and make sure that they can still talk even though they don't technically know talk the same language. The live switch media servers are highly available, so you can deploy as many as you need to support your load. And they will auto-cluster if the load on an individual media server exceeds what it can handle. So the gateway will basically direct traffic from clients to a given media server. Once it exceeds a certain threshold, it'll start directing traffic to a secondary media server, and those two media servers will form the beginnings of a cluster. And that just kind of expands and expands as your client user base demands more from the system. So the final kind of server-side piece is the live switch SIP connector. What this does is it provides the bridge to what Ted mentioned earlier about the legacy VoIP and SIP and PSTN world. As long as you have some sort of a soft PBX or a SIP trunk or something that talks SIP, you can use the live switch SIP connector to bridge in cell devices, landlines, VoIP phones, soft phones, anything that is SIP capable. And that's bidirectional. So there's the option to have them dial in to an existing room or an existing session conference, or the client SDK actually allows you to dial out to a registered phone number and invite them into the conference. All right, and lastly here we have kind of as a wild card at the end. The live switch SIP connector is actually built using a live switch connector SDK that allows us to build custom connectors for any other type of system that may support standards-based RTP media, but uses a different signaling system. For example, a couple of things that are on our longer-term roadmap here are H323 integration and RTSP integration for IP camera support. Those would both be built using the connector SDK to essentially translate between the signaling language of live switch and the signaling language of this third-party system, like that may be H323 based or RTSP based or something else. The actual media connections still get formed with the media server. It can still be consumed by all of the client SDKs and all of the client platforms, and the connector just performs the translation for this third-party system. Okay. So now that we've talked a little bit about the technical architecture of live switch, I'd like to talk just very briefly about some of the common applications that we see and how live switch is used to address their needs. So the Hello World example of the WebRTC and VoIP world is just a two-party call. In this case, we have Susie and Bob who want to talk together. They may want to talk together over a peer-to-peer connection. They may want to connect to each other over an SFU connection. They may want to maybe talking different protocols completely and want to use the MCU to do the transcoding between the two. Either way, live switch can make sure that they're able to talk to each other and see and hear each other. Live switch has full support for text chat within these calls, screen sharing, data channels for whiteboarding, or as Ted alluded to, diagnostic data or any other information that you might want to transmit back and forth, as well as full support for SIP interoperability in case one of these two endpoints is actually a traditional phone. We have full support for Apple CallKit, so you can integrate with iOS nice and tightly. Extending that out a little bit, we have what amounts to a conference. If you have 3 people, 4 people, 5 people, everybody's sending and receiving audio and video, they're all talking with each other, we would consider that a conference. And that's just a natural extension in our world of a call. You can just easily add more participants the same way you add your third participant the same way you add your first and your second participants. In live switch, everybody kind of joins into the same channel, and whether that's two people who are having a two-party call or 4 people having a 4-party conference, it's kind of up to your application to decide. Extending that a little further, we have what we're running right now, which is a webinar where we have a number of participants that are in kind of a receive-only or listen-only mode. Live switch can easily handle this and broadcast out to a large number of participants that don't actually contribute back into the conference itself. They can all be on different platforms. They could be running different codecs. They could have different requirements. And that's all handled automatically by the live switch media server. We currently support VP8 and H.264. Support for VP9 with its SVC capabilities is coming very soon. So we'll be able to see improved bandwidth adaptation for low bandwidth participants. Okay, extending it out even further, we have what we refer to as broadcasting. So technically you could call what we're doing now in a webinar as a broadcast, but it's fairly small scale. We generally use the word broadcasting to refer to a rather massive scale, thousands, tens of thousands, hundreds of thousands of people viewing a live feed. This is where LiveSwitch media server clustering comes into play. And as long as you have the servers in place to handle the load, you can just keep adding more load to the system, and the LiveSwitch gateway will automatically bring in more media servers from its available pool to handle the load as it drives upwards. Okay, and then the last piece here before I hand things back over to Ted is to talk just a little bit about recording. So LiveSwitch supports recording. It does so on the server, and it does so in a very raw form. It tries to keep things as performance intensive as possible. We try to avoid any extra overhead that's not necessary. And so we write out the raw streams to disk as they arrive at the server very, very quickly, and keep recording from reducing the capability of the server to handle the actual live conference. After the conference is completed, all of those raw streams can be transcoded to different formats. They can be muxed back together. They could be converted from VP8 to H.264. Container formats can be shifted around. Everybody's requirements are a little different when it comes to archiving. There might be legal requirements in place, and we can, of course, help you get you through all that. And that's it for me. At this point, I'd like to hand things back over to Ted to wrap things up.
Thank you, Anton. So as Anton has covered, LiveSwitch is IRTC. If that's the message you're getting, then that's the correct message. Basically, we recognize the fact that IRTC consists of many different things, as we've talked about earlier, and LiveSwitch is capable of actually handling all of these for you in a very consistent, smooth, and single fashion. So you can have one-stop shop. You can come here, use LiveSwitch, and it will handle all of these, of course, in a very naturally integrated fashion. Before we sort of reach the end of our presentation and go to some questions and stuff, I do want to mention a couple more things about Frozen Mountain. First of all, Frozen Mountain does offer professional services, and basically we offer them in three distinct different categories. We offer what we call IRTC assessments, where we can come in and over a short period of time look at your architecture, decide how best to put things together given all the pieces that we've discussed today that could play into it, and what's the best way, what's the best design for your architecture. So basically the IRTC assessment is a design capability. We also have IRT fast starts, which is we recognize the fact that this technology can be complicated. Phil alluded to that too. You want to make sure the thing works. You don't want to have that situation where the attaboy gets you because you make that one big mistake. So sometimes it's very, very helpful to use one of our specialists as part of a project for a period of time in order to get you going quickly into the IRTC and into what is all involved in actually doing an IRTC project. And then, of course, we'll actually do complete IRTC projects for you as well. And we have done many of those in the past. We're also very pleased today to announce the fact that we've just formed a Frozen Mountain Partner Program. The Frozen Mountain Partner Program is for those of you that are out there who develop applications for third parties. We recognize that a lot of people are out there developing applications, also need this information, want the information, and want to be able to use LiveSwitch as part of their offerings. So the Frozen Mountain Partner Program is for application development companies and WebRTC advocates. We will actually pay you a commission, a share of revenue from all of the product sales you refer to us. We will also lock on with certain customers. When you register a customer with us, we will not offer them services without your permission. And you can get referral credits for leads actually originating from your website. We can track that if you have us on your website, we can track the fact that customers came from your website, and we will give you credit for that. So to learn more about the Partners Program, please, after the presentation, feel free to go have a look at frozenmountain.com/partners. At this point, I'd like to turn it back over to Phil so that we could actually carry out one more survey question. Phil, so over to you.
Thanks very much. So this next survey question is really, I think, very interesting. It's first we talk about expertise, and we see that a lot of you are just starting out in understanding how to apply WebRTC to your applications. So this is a very interesting question. What would you be interested in a future topic in this stream, a next webinar? Is it WebRTC and specific vertical applications, integration with telephony, special devices and IoT? And this is a real opportunity to help kind of form the agenda both for TMC, WebRTC world, as well as for Frozen Mountain, about the areas that are of most interest to you. So we'll go ahead and let you respond to those questions in the question window. In the meantime, though, what I'd like to do is start with some questions, for the Frozen Mountain team. So the first question is the Opus codec supported in your implementation?
The answer to that is yes. We actually support 3 audio codecs, PCMU, PCMA, and Opus. Opus is generally the preferred codec to be used wherever possible. It's really high quality, really high fidelity. PCMU and PCMA generally only get used when we're dealing with SIP interoperability. But yes, it is supported.
Excellent. Before we kind of jump back to the survey, I'd ask one other question that is really about LiveSwitch. And you were discussing recording, and the question is, can LiveSwitch record the data channel and archive that as well as more traditional voice and video recording?
That is a very good question. The answer to that is currently no, but I will bring that question back to the team because that is a very interesting idea.
I think that was a very interesting one also. It raises very interesting questions at lots of different levels in terms of capability, in terms of application, but also in terms of things like security, et cetera, as well. So, another area that's pretty critical. So one more quick question here, and then we'll jump back and look at the results of the survey. Is transcoding being used during broadcasting? You talked a bit about broadcasting, kind of the capability to do large-scale broadcasting. I think something that we're seeing becoming very exciting, kind of live streaming and live interactive streaming. Is there transcoding being used in that, and how does that impact? And we actually have a second question that relates pretty directly to that, which is talking a bit about latency. So maybe talk a little bit about transcoding and latency and kind of the performance capabilities that you see in broadcasting.
Sure. So transcoding, the answer is transcoding being used during broadcasting? The answer is yes and no. It depends. So transcoding in LiveSwitch happens automatically. If the person sending the video up to the server supports, for example, the VP8 codec and ends up using the VP8 codec, and the listener on the remote end also supports the VP8 codec, there will be no transcoding. It's a direct forward through. If the remote peer supports, for example, only H.264, then the video stream will be transcoded, and there actually is a slight extra latency for the transcoding. So peers that don't support the full WebRTC spec, may actually end up receiving a slight delay in the broadcast. So tied to that, the latency that's generally seen with broadcasting is sub-second when we're using WebRTC. The more traditional technologies using HTTP live streaming introduce like anywhere from 6 seconds to 30 seconds delay on the live feed, and that's one of the things that we're trying to work to improve. By using WebRTC to broadcast the feed, you can actually get down to sub-second latency, oftentimes sub-500 milliseconds latency, based on the round-trip time to the server that's actually doing the broadcast.
Well, and I think that's very important because it's not just about broadcasting, or we traditionally would think of as streaming, which is just one way, and where you can use buffering to kind of protect and manage things. This is much more interactive broadcasting, I assume, where you may have multiple speakers, and therefore you actually real time across the whole gamut is actually fairly critical.
Absolutely.
Excellent. So I think we're going to jump back now before we go to the next few questions and look at our survey results. So very interesting. Very much a spread. Clearly lots of interest. Customized WebRTC application development and WebRTC for devices is definitely a critical area where there's a lot of interest. So those definitely are topics to look forward to in the future. And in fact, that kind of leads directly into another one of the questions, which is what is the capability set for devices that are medical devices? I mean, how do you work with medical devices? Are you seeing medical devices beginning to have this capability, or do they have the capability of developing and putting protocol stacks into them. How does that work in this range of devices, starting with medical devices and then IoT as well?
Sorry, can you repeat that question?
Oh, so the question was really around device integration. So, we see here that, there's a lot of interest in device integration. There's interest in telemedicine, but devices in general. So when you look at devices that are not traditional mobile devices or PCs or browsers, beginning to look at those, medical devices and then some of these IoT devices, how do we get the protocol stack into them, do the implementations? Are those devices beginning to become, IRTC ready? Kind of where is the whole status of?
That's generally driven by our client stack. So we see a lot of special devices in the telehealth and medical field. And the LiveSwitch client side stack is actually, it's built from the ground up by us, and so we have a version that runs entirely in C#, we have a version that runs entirely in Java, and we have a version that entirely runs within Objective-C and Swift. So since most embedded devices are running Linux, we can often take our Java SDK or our C# SDK and deploy it to an ARM-based embedded system like a Raspberry Pi or an embedded medical device, and get a video stream off of that device and actually stream it out, and also process inbound streams with relatively good efficiency.
Excellent, excellent. So we have a question really around the infrastructure needed to run LiveSwitch. So if I'm a customer, I've decided to deploy LiveSwitch and use it. Kind of what's the entry requirement, and then I think the second question really is around how does it scale? How does the platform scale? Those are actually two questions. So maybe talk a bit about initial deployment and scaling, and how you go through that process for somebody who really decides this is something they want to deploy.
Right. So the minimum requirement to run a LiveSwitch server is just a single server. It can be Windows or it can be Linux. Our current release that's live on our website is Windows only, and we have a Linux version that is tested and ready to go and just going through the final steps of being packaged up so that you can deploy to a Linux box. It has full support for Docker. We haven't tested with Kubernetes, but it is platform agnostic. The entire thing is built using C and .NET Core. So as long as the platform is Linux-based or Windows-based and can host a .NET Core type application, then you can deploy it to that infrastructure. For high availability and failover, we would generally recommend at least 2 servers, but for development and testing, you could definitely get away with just a single box.
Excellent. So it starts small and can scale fairly rapidly.
Absolutely.
So another transcoding question just was really around, what's used for transcoding in LiveSwitch? How does the transcoding work in LiveSwitch? Because, clearly, transcoding, especially when you're integrating back with kind of the legacy video world, is critical, as well as, in the MCU function, bringing different things together. So tell you a little bit about how your transcoding is implemented.
Definitely. So we use standard C libraries, reference implementations for libvpx and for H.264. Same for Opus. We use libopus, as well as our own internal implementation of the PCMU and PCMA codec.
Cool. So you've done a lot of codec work there.
A lot of codec work, yeah.
So one question, and this is a question that I get a lot. Maybe you can talk to it a little bit. Maybe turn it into maybe a more general discussion. One of the I would call it technical philosophical questions that's happening is, what happens with smart devices? Clearly, the last 7, 8, 9 years of smart devices has been around downloadable applications written to the native iOS, native operating system within the device. And basically a world of app stores and that. Clearly, there's the option of apps being built directly into the browser. As we get more processing power, the abstraction and the additional processing begins to be less important. And so the question really here very specifically is are there any restrictions with WebRTC when using browsers on iOS devices? And I would extend that not just to iOS and Apple devices, but also to Android devices. Can you get access to cameras? Can you get access to media in those smart devices? Or are we still a ways away where it still makes sense today in smart devices to do native apps? So I think that's kind of the question is, what about browsers in those smart devices?
So the landscape there has improved quite a bit. It was fairly nasty even 6 months ago. When iOS 11 came out and added support for WebRTC into Safari, that made a really big difference. So you can absolutely, using Safari on iOS, you can deploy a WebRTC-based web application, and on Chrome on Android you've been able to do it for a while using Chrome or Firefox, and I believe Opera supports WebRTC on Android as well. There are some caveats there. Safari on iOS currently only supports H.264. They don't support VP8, which technically makes them not WebRTC compatible, but it just complicates things. And Chrome on Android generally supports VP8 only. They actually go the other direction. And H.264 is only enabled on a handful of select devices. So peer-to-peer communications between mobile web browsers is actually quite not great. It doesn't work that great. But if you put a LiveSwitch media server in the middle to do the transcoding, then everything works nicely. But as Phil alluded to, there's a bit of a philosophical question here about deploying native apps versus web apps. Obviously, the experience is quite different. So you'll definitely want to consider what you want your user experience to be, whether you want push notification integration, whether you want the app to run in the background, that sort of thing.
That's absolutely true. I mean, it was very interesting. I saw an app at a recent event that was actually not an app at all. It was just a URL, but was kind of positioned as an app. And it was kind of interesting to see very technical people try to get their head around something that's really just a URL that's called an app. But from a regular user perspective, an app is just the icon they tap on the device to get to something happening. I'm sure this is a question that you'd love to talk to. So as a sales question, can you talk a little bit about the licensing model that you're deploying, for IRT releases and with LiveSwitch?
Ted, that would be more of a question for you if you don't mind answering that one.
No, certainly. I can take care of that one for you, Anton. So basically, we license LiveSwitch on two different models. The first one is per minute. So based on the number of minutes that you actually make use of the product, it's expected you're going to be running it also in a cloud environment, which is also charged per minute. But secondarily, and it often works out better, is we also charge for LiveSwitch on a maximum concurrent user model. So for example, if you're in a telehealth application and you have doctors and patients and everybody interacting with each other all the time, you may well have 1,000 people in terms of all your doctors and patients that communicate with each other all month long. But if in reality they only have 20 of them communicating at any one time, then you only pay for 20 users. So it's basically the maximum number of concurrent users, the number of users that are streaming audio and video at any given time during the month. So whatever the maximum of that is, you pay for that on a per user basis, which works out very well especially for applications that are randomly spread and where people are just using it on and off throughout the month. Then you have maybe potentially many users, but not all that many at the same time. Having an application with many users exactly at the same time, other than for a large broadcast webinar, is not that common. Depends on the application. So we provide two models that allow you to go either way depending on the model you wish.
Excellent. So just a confirmation. It's great when you have a question that comes back and says, "I can't believe that you said you could actually do that," but that the confirmation that transcoding in LiveSwitch could be achieved in less than 1 second latency. So just someone confirming that you actually are achieving that as a capability within the platform.
Yeah, that is correct.
Great. That was an easy one. So next question is, what's the role of SBCs in the IRTC deployment? Do you work with different SBC vendors? How do you work with SBCs? And I imagine that's both a work with and work around question as well.
Mm-hmm. That's kind of a big question. SBCs or session border controllers are fundamentally they're SIP based, so they should be fully interoperable with our SIP connector. We've actually worked extensively with Sonus prior to their acquisition by GenBand, and did very extensive testing with our core stack against their SBC. And so in theory, as long as the SBC supports proper SIP and SDP features, then you can absolutely use an SBC within the LiveSwitch ecosystem or vice versa. We don't have access to all of the SBCs that are out there, but we could certainly set up a test case if you had a particular SBC in mind that you wanted to try out. We could work with you to give that a go and then see how it works.
Excellent. So I think we have time for one last question. Those questions we didn't get to here, there were a few. I think those will be they'll be followed up directly with a direct answer. So kind of the last question is around, again, scaling. Are the servers working in tandem, or is there a limit to endpoints registering on a particular server for a particular customer? I think the question here is, how do multi-party sessions extend beyond servers, when you get into some of these capacity mechanisms? So how do you kind of manage that? Kind of a discussion of that architecture, I think, would be important.
Yeah, so the servers do work in tandem together. They coordinate, and it's the gateway is kind of the puppeteer or the gateway cluster. They orchestrate all of the media servers. So when a client wants to connect to a media server, what it does is it talks to the gateway and says, hey, I'm in this channel, I want to open a connection, I want to receive this feed. And the gateway turns around and says, okay, go ahead and talk to this media server over here. If that media server exceeds a certain threshold, which is configurable, CPU bandwidth, overall network usage, then it will automatically start directing clients to a secondary media server and form a cluster between the two. So they definitely work in tandem together. There is not really a limit to how many endpoints you can keep going. As long as you have the server resources and your data center can handle all of the internal traffic, then you can theoretically keep expanding it out and adding in additional servers to support additional people joining the conference or joining the broadcast if they're listening only.
Excellent. Well, thank you very much. I think that was a great set of questions and answers, and it's an outstanding topic, and clearly with the questions we had and the participants, it's of great interest to the audience as well. With that, I'd like to first thank everyone who attended the webinar for coming today. Hopefully you learned some things, and this will help you on your journey to real-time enabling your applications, your business, and generating new revenue and new opportunities. And I'd like to thank Anton and Ted for a very illuminating presentation and exciting news about a new product that really can help people with their deployment in this category. So with that, thanks again to everyone. Final reminder, the presentation is available in the archives, and there is a URL that is being pushed to you to respond, and clearly on the screen, if there are any questions, sales@frozenmountain.com is a great place to get those answered, or there's an 800 number on the screen you can call as well. Thanks again. Great appreciation to Ted and Anton, and hope everyone has a great rest of the day, and look forward to speaking with you in the future. Good day.